Dear students, let us study what are bases and what are the properties of bases in this period. Welcome you all for the period. Dear students, here are few examples for bases. The examples are sodium hydroxide, potassium hydroxide, calcium hydroxides. These are few examples, common examples for bases. Let us look into the molecular formula of these bases. Sodium hydroxide, its molecular formula is NaOH. Potassium hydroxide, its molecular formula is KOH, and calcium hydroxide, its molecular formula is CaOH twice. Calcium hydroxide, otherwise called lime water. So the molecular formula of lime water is CaOH twice. See students, these three molecular formulae have some common in them, that is OH ions. So sodium hydroxide has OH ion, potassium hydroxide has OH, and calcium hydroxide also has OH. So when these bases are added to water, they release OH minus ion. So that is the meaning of bases. If the question asked what are bases, you may answer a bases are a chemical compound. Yes, these are all chemical compounds. See, sodium hydroxide contains 3 elements, so it is a chemical compound. Potassium hydroxide contains 3 elements: potassium, oxygen, hydrogen. Yes, it is also a chemical compound. Then calcium hydroxide also contains calcium, oxygen, hydrogen. 3 elements are there. So all these 3 are chemical compounds. When these chemical compounds are added to aqueous solution or water, they release OH minus ions. So what are bases? Bases are the chemical compounds that release OH minus ions in aqueous solution. Then bases are another definition. Bases are compounds which give hydroxide ion in the water solution. Hydroxide ion is nothing but OH minus ion. So bases can be defined in another way. A base is a substance that can accept hydrogen ions from other substances. So any substance which has H plus ion, the base can react with it and absorb that H plus ion, and that H plus ion reacts with OH minus ion to form water. So the base is a chemical compound that accepts hydrogen ion from other substances. Then if you can define a base in another way, bases are bitter in taste. They are bitter in taste and soapy to touch. They have slippery in nature and they can change the red litmus to blue color. So these are some of the definitions and few examples for bases. Next, let us study the properties of bases. So bases are bitter in taste. They have bitter in taste. Then all bases give hydroxide ion, that means OH minus ion with water. So when bases are added to water, they release hydroxide ion. This is the second property of a base. Bases turn red litmus to blue color. See, this is the red litmus. Here in this beaker we have taken some bases we have taken. When red litmus dipped into a base, the red litmus turns to blue color. See here, the blue color. Then if you take a base in a electrolytic cell, base conduct electricity in aqueous form. So if you add base into water, that can conduct electricity. So this is another property of a base. Bases neutralize the solution containing H plus ion. This can be otherwise defined as bases react with acid to produce salt and water. This reaction is called neutralize reaction. Even neutralization reaction can be a property of acid as well as a property of a base. So both acids and base react with each other to produce salt and water. So that is another property of a base. Next, let us continue. Let us study some more properties of bases. Bases also react with metals that give salt and hydrogen. When if you add bases, strong bases over metals like zinc, they can produce hydrogen gas if it is heated. So this is another property, but not all metals react with all bases. Then another property of bases have a slippery or soapy feel. They have slippery in nature. Bases dissolve fatty material in them. So it is your common experience if some oil or greasy material or any fatty material comes in contact with your skin, to remove it you have to wash it with soap. Soap is a base. Then solution of base absorb carbon dioxide to form carbonate. Lime water test we have discussed just now. So lime water, that means it is a base, calcium hydroxide. If you allow carbon dioxide to dissolve in lime water turns milky because calcium carbonate is produced. So in this experiment, lime water experiment, it is clear that if you add carbon dioxide to any base, some carbonates are produced. See, this is the chemical change. It is refers to this when metals react with sodium hydroxide. Sodium hydroxide is a base. This base reacts with metal to produce one salt and hydrogen gas. Okay, you have discussed some properties of bases in this class. Now, acids and bases can be grouped into two ways. You can group acids into strong acid and weak acid, then concentrated acid and dilute acid. Now let us in this period, let us discuss what is the meaning of it. Strong acid means the acid which is rich with H plus ion. Any acid contains more H plus ion in it, then it is called strong acid. Or otherwise, when an acid is added to water, if it undergoes complete dissociation and or ionization we may call. So if complete dissociation, for example, you have taken nitric acid. If 100 molecules of nitric acids are added to water, if all the 100 molecules undergo decomposition or disintegration or dissociation and produce 100 H plus ion, then it is called a strong acid. If any acid when added to water, if it dissociate partially, then it is called weak acid. So these are all some example for strong acids. Now let us study weak acids. As I told you earlier, weak acids or acids, they do not completely dissociate. They dissociate only partially. For example, carbonic acid. 100 carbonic acid molecules are added to water. If only 20 molecules dissociate or divide or break down, then remaining 80 molecules remain as it is. Then it is called a weak base. And weak base means the base which has less amount or less number of H plus ions. The Acids which are having less number of H plus ions are called weak acids. Here are two examples. See, carbonic acid, otherwise called soda water, and acetic acid, otherwise called vinegar. So these two are examples for weak acids. Then comes, on the basis of concentration, acid can be classified into dilute acids and concentrated acids. Now let us study what is dilute acid, what is concentrated acid. The acids which have low concentration of acid, that means less amount of acid is there, more amount of water is there, then it is called dilute acid. Acid concentration less, water concentration more, then it is called dilute acid. The acids which having high concentration of acid, that means it contains more acid molecules and less molecules of water, then it is called concentrated acids. Similarly, we can group the bases into four types: strong bases, weak bases, concentrated bases, and dilute bases. Now let us study one after the other. So you have the knowledge of acids now, so based on that you can understand the bases also. Strong bases are those bases which completely dissociate into ions in the aqueous solution. Example, sodium hydroxide. When sodium hydroxide, 100 molecules of sodium hydroxide are added to water, all 100 molecules are dissociate into ions. Then it is called a strong base. So strong base are those bases which ionize fully, completely dissociated and produce large number of OH minus ion, then that is called strong base. Then weak base are those bases which do not undergo complete dissociation. That means they partially dissociate in the aqueous solution. They produce less number of OH minus ions, then they are called weak bases. Example for weak bases, ammonium hydroxide and magnesium hydroxides are examples for weak bases. Then let us study the meaning of dilute and concentrated bases. As you know, bases which have low concentration of base and high concentration of water, then it is called dilute base. The base which have high concentration of base and less concentration of water is called concentrated bases. So with this we have completed a few different types of acids and bases. Thank you for listening the class.